Assalamualaikum warahmatullahi wabarakatuh. My name is Nurin Jazlina binti Muhammad Hadim and I'm from PITDS Gunjuman. So today we're going to present about input-output module functions. So what is the meaning of input-output? Input-output is defined as a subsystem of components that move coded data between external devices and a host system consisting of a CPU and main memory. I/O subsystem include blocks of main memory devoted to I/O functions, buses that move data into and out of the system, control modules in the host and in peripherals devices, interfaces to external components such as keyboard and disk, and lastly, cabling or communication links between the host system and its peripheral. Why an I/O module is required? Firstly, there is a wide variety of peripherals with different methods of operation. Second, peripherals data transfer rates are more slower than the processor or memory. Third, some peripherals operate faster than the processor or memory. So what is I/O module operations? An I/O module is a hardware component that provides an interface to the processor and main memory via the system bus, an interface to one or more peripherals devices through tailored data links. The I/O module hides the details of the device operation from the processor. So this one is the generic model of an I/O module. First, we have control signals. Second, data signals. And third, we have status signals. So what is external devices? An external device is attached to the computer by a link to an I/O module and exchanges control, data, and status information. So what is the category of external devices? We have three. First, we have human-readable devices, which is keyboard, video display, terminals, and printers. Second, we have machine-readable devices, which is magnetic disc, magnetic tape, sensor, and actuators. And the third one, we have communication devices, which is network interface cards, which is NIC, modems, and wireless adapters. So this one is the signal between I/O module and external devices. So first, we have control signals, which is specified operations such as read, write, seek, or report status. Second one, we have data signals, which is carrying data between the device and the I/O module. The third one, we have status signals, which is indicate device status such as ready and busy. So this one is the major functions of an I/O module. First, we have control and timing. Coordinates the flow of data between internal resources and external devices. Second, processor communication includes command decoding, data transfer, status reporting, and address recognition. Device communication sends control signals to the device, receive data and status information. We have data buffering to, which is temporarily stores data during transfer, compensates for speed differences between devices and CPU. We have error detection, which is it detects transmission and device error and reports error to the processor. And here we have I/O commands, which an I/O module can receive four types of command, which is control, test, read, and write. So addressing of I/O devices. Each I/O device has a unique address used by the processor. Firstly, memory map I/O. I/O devices share address space with memory. Second, isolated I/O. I/O devices has a separate address space. So this one is the spectrum of I/O module. First, we have I/O controller. I/O controller basic I/O module and high processor involvement. Second one, I/O channel, which is I/O processor, advanced I/O module, and low processor involvement. So this one is how the I/O module simplify processor work. So the I/O module hides device timing differences, data format differences, and electrical and mechanical operations. The processor only issues simple commands such as read and write. So the summary, the I/O module acts as an intermediary between the processor and external devices. It controls data transfer timing, buffering, and error detection, and it enables efficient and reliable I/O operations. That's all from me. Thank you.